We worked on this class before. We implemented the Fibonacci number generator. We wrote the constructor, the hasNext, and the next method. And then we also wrote the main, where we're just generating the first 25 Fibonacci numbers using the hasNext and the next. And the way that we created our Fibonacci object was pretty common. We said Fibonacci f, and then we created the Fibonacci object. These are things we have seen before, just summarizing here. Now, since we have implemented a hasNext and a next method, which are the methods that are required by the iterator interface if a class wants to implement it, we can just say that our Fibonacci class that has exactly the same constructor, hasNext, and next methods is implementing the iterator interface. I have not changed the implementation of any of these methods or the constructor. The only thing that I have changed is that the return type for next now needs to be integer instead of int as we had before. And the reason has to do with the fact that the iterator needs to have as a return type for next something that is of object type. And integer is a class that can be used instead of that. We will see at a later lecture that it inherits from the object class, and this is the reason. But for the moment, just bear with me on this. So the only difference that we have pointed out so far between the Fibonacci 2 implementation and the Fibonacci 1 implementation is this difference that next is returning an integer because the Fibonacci 2 is implementing the iterator. Let's take a look at the way that we have written main though, and specifically line 31. Here we have said, instead of saying Fibonacci f becomes equal to new Fibonacci 2, we have said iterator I1 becomes equal to new Fibonacci 2. Now we can use, since the class is implementing the interface, we can use an iterator variable. Nothing much on the way that we use it so far, but it is just a difference that it is worth pointing out. We can call the hasNext and the next through the iterator variable. In the next version that we're going to see, the Fibonacci 3, we have our class implement not only the iterator interface, but also the iterable interface. What changes do we have to do because of that? The iterable interface asks us to have an iterator method, which returns an iterator variable. What should we then return in the iterator method? We need to return an object through which we can call hasNext and next for this Fibonacci generator. What is this object? Well, it is this object. A Fibonacci object is able to call hasNext and next. Therefore, we just need to return this in the implementation of this method. Now let's move on to see one more difference and why we actually want to be able to implement the iterable interface. The first lines of code inside main is exactly the same as the piece of code we saw at the previous version of Fibonacci that was only implementing the iterator. What we can now do that we're also implementing the iterable is that we can use the for each loop. And how do we do that? We have an iterable variable referred to a Fibonacci object, and then we use this variable as the collection over which we're going to get elements in the for each loop. Notice that because I here, the element of the list, is an object, this is how we can write the for each loop. We need, when we print the value of that object, we are typecasting back to integer. So this is the additional flexibility that implementing the iterable interface gives us.